Okay, the first composition we're going to do is we're going to do the inverse sine of sine x. Inverse sine of sine x. If those are true inverses of each other, remember everything cancels out and we would be left with the x. Okay? Now, remember your order of operation. Remember that if you have something in parentheses, it is done first. Okay, so in this case, our sine x takes priority. So what we do in that case is we go back to the domain of our sine. So what is the domain of your sine function? What's the domain of your sine function? Negative pi over 2 to pi over 2. Okay? So in order to get back the x or whatever is in x's place, you know that you must stay in the domain of your sine x. Okay? Now, let's come over here and we're going to clip it. So now we're going to do sine of sine inverse of x. In order for this to work, we know that we must stay in the domain of our inverse sine. What is the domain of your inverse sine? What's the domain of your inverse? Negative 1 to 1. Okay. All right, let's move on to cosine. All right, we'll start with inverse cosine. And we will put cosine inside of that. So we must stay within the domain of our cosine. What's the domain of our cosine? From 0 to pi, yes. Keep wanting to write that S. And then our cosine of inverse cosine of x equaling x. That must stay in the domain of your inverse cosine, and the domain of your inverse cosine is what? Negative 1 to 1. And our tangent so if we take tangent inverse of tangent x, it is the tangent x that we must stay in the domain. And what is the domain of your tangent? Okay. This one is between, right? So how would we show that in interval notation? With the what? With the parentheses, yes. So negative pi over 2 to pi over 2, not including. All right, and then tangent inverse of x equal to x. So tangent of tangent inverse of x, that means we must stay within the inverse tangent domain. And that one is what? The domain of your inverse tangent. Negative infinity to positive infinity, or all reals. Okay. So let's look at some examples and see how this works. You've kind of been practicing it. We're just going to kind of put it together here. All right, let's take cosine inverse of cosine pi over 6. All right, so we have our cosine inside the parentheses, so it is the domain of the cosine that we want to focus on. If we look at the domain of the cosine, we see that that goes from 0 to pi, right? So it goes from 0 to pi, so this is the one we're looking at here. Is pi over 6 between 0 and pi? Yes, it is. So, if this is within that domain, we are taking inverses of each other, what would our answer be? Yes, it is in the domain. So the inverse cosine of cosine pi over 6 would give us what? What happens? Everything cancels back and we get back what? And what is our x in this case? Pi over 6. So that gives us back our pi over 6. Okay. Okay, let's take sine of sine inverse of 1. Sine of sine inverse of 1. Okay, so it is the inverse that is in the parentheses. So that is the one we will be looking at for our domain. Okay. So our domain must be where? Yeah, between the -1 and the 1. So, is the 1 in the domain? Yes. Okay, so what would that equal then? It would just equal the 1, right? Let's take tangent inverse tangent 7 pi over 4. Okay, so tangent domain is what we would be looking at here. So we're working with this one here. Tangent domain is between what? Negative pi over 2 and pi over 2. Well, does 7 pi over 4 work for this one? No, 7 pi over 4 is where? That's over here in the 4th quadrant, right? So we're over here in the 4th quadrant. That's not going to work. So we're going to have to approach it the other direction. So if we come this direction, what would that give us? Negative pi over 4. Okay. And let's do one more. Let's do sine inverse of sine of 2 pi over 3. Okay, so sine is in the parentheses, so that is the one that we will pay attention to. So that is between the negative pi over 2 and the pi over 2. So how about 2/3 pi? Does that lie within the domain? Where is 2/3 pi? 2/3 pi is in quadrant 2. Okay, is that between the negative pi over 2 and the pi over 2? No. Okay, so this one's a little different. All right, so 2 pi over 3 is in that third quadrant. Quadrant 2, so we have gone out of our domain. So we look at the value of sine, which is positive square root of 3 over 2. If we go back over to quadrant 1, we see that our sine positive square root of 3 over 2 is at pi over 3, so that would be our answer. All right, so cases 1 and 2, examples 1 and 2, we stayed within our domain. So our input equaled our output, right? Because we stayed within that domain, and that will happen. Case 3, examples 3 and examples 4, we were out of our domain that we needed, so we had to find the angle that was within the domain of what was inside the parentheses. In this case, the tangent, regular tangent, and then in this case, the sine. So in these last two cases, our output really did not match, right, the input like the first two did. In one case, we found the coterminal, and in the other case, we had to resort back to which value was the same, that square root of 3 over 2.